Welcome back to the Dargslan Networking Mastery Curriculum. You've made it to Lesson 6 of Stage 1, and this is where the network starts to take physical shape. Today we're exploring network devices, hubs, switches, routers, firewalls, and load balancers. Each one plays a very different role, and the easiest way to understand them is by looking at which OSI layer they operate on. Let's dive in. Here's the path we'll take together. First, we'll start at the foundation with hubs, switches, and routers, the classic trio that lives at layers 1, 2, and 3. Then we'll move up the stack to firewalls, which make security decisions at layers 3, 4, and even 7. After that, load balancers, where we'll compare layer 4 versus layer 7 traffic distribution. And finally, we'll look at how modern hardware blends all of these roles into single multifunction devices. Before we dive into each device, here's the whole landscape on one screen. Notice how every device climbs a little higher up the OSI stack. A hub decides nothing. A switch reads MAC addresses at layer 2, a router jumps to IP at layer 3, and firewalls and load balancers reach all the way up to layer 7, where they can inspect things like HTTP headers. Keep this idea in mind as our anchor. The layer a device operates on defines exactly what it can and cannot decide. Let's start at the bottom of that stack with the hub, a layer 1 device that frankly thinks about nothing at all. When the sender transmits a frame, the hub simply repeats those electrical signals out every other port. So host A, host B, and host C all receive it, even though only host B was the intended target. That's why hubs are extinct today. Every device sees every frame, collisions waste bandwidth, you're stuck in half duplex, and there's essentially zero security. Switches replace them everywhere, and that's exactly where we're headed next. And here's the upgrade. A switch operates at layer 2, which means it actually reads the destination MAC address on every incoming frame and consults a table like this one, mapping each MAC to the specific port it lives on. So, when host A sends a frame destined for BB, the switch looks it up, sees port 2, and forwards it only there. Hosts CC and DD never even know the conversation happened. That's intelligent forwarding instead of blind repeating. Now, not all switches are created equal. They come in 3 broad tiers. At the bottom, unmanaged switches are the €30 plug-and-forget boxes you drop into a home or tiny office. They learn MACs automatically, and that's it. Step up to managed switches, and suddenly you can carve the network into VLANs, apply QoS and ACLs, and monitor every port over SNMP, perfect for small businesses and branch offices. At the top, Layer 3 or core switches add routing between VLANs, OSPF, and wire speed forwarding, which is what holds an enterprise backbone together. Same basic layer 2 job, but with very different brains inside. And once we step above layer 2, we meet the router, the device whose entire job is connecting different networks together. Here, network A on 198.168.11.024, and network B on 10.0.024 live in completely separate broadcast domains, and the router is what lets them talk. When a packet arrives, it reads the destination IP, finds the best match in its routing table using longest prefix, decrements the TTL, rebuilds the layer 2 header for the next link, and forwards it out the right interface. That's the layer 3 decision loop in a nutshell. Now, routing decides where packets can go, but the firewall decides whether they're allowed at all. The earliest kind, stateless filtering, just looks at each packet in isolation, source, destination, port, fast but blind to context. Stateful firewalls, today's industry standard, actually track connections so they know if a packet belongs to an established session or is something brand new knocking at the door. And then next-gen firewalls go further, peering into the application itself, recognizing BitTorrent or Office 365 by behavior, tying traffic to a specific Active Directory user, and even inspecting inside TLS. Same gate, just smarter at every layer. From gatekeepers, we move to traffic directors, load balancers, which spread incoming requests across a pool of back-end servers. The key distinction comes down to which OSI layer they operate on. A layer 4 balancer only sees IP addresses and ports, so it just picks a backend, often round-robin, fast, protocol agnostic, and used in things like AWS NLB or chat proxy in TCP mode. A Layer 7 balancer reads the actual HTTP request, so it can route by path or host name, sending DO API somewhere, static to a CDN, and handle TLS termination too. Same job, but the higher the layer, the smarter the decision. Now here's the catch. In the real world, you almost never buy a device that does just one thing. That cheap home router in the corner of your living room, it's actually a router, a switch, a Wi-Fi access point, a DHCP server, a NAT engine, and a basic firewall, all crammed into one plastic box. Scale up and the same pattern holds. An SD-WAN appliance bundles routing, VPN, and firewall with cloud management. An AWS application load balancer adds WAF caching and TLS termination on top of Layer 7 balancing. And a modern Wi-Fi AP often includes a built-in switch and VLAN tagging. So when you're identifying a device, don't ask what it is. Ask which layers it operates on and what jobs it's doing at each one. So let's put everything we've learned into a single picture. Traffic from the internet hits the firewall first. That's our Layer 3 through 7 guardian, inspecting addresses, ports, and even application content. Behind it sits the Layer 7 load balancer, distributing requests based on URLs and headers, which then hands off to the Layer 3 core switch for routing between internal segments. And at the bottom, 3 Layer 2 access switches connect the actual end devices. Each box has a clear job, defined by the layer it operates on. With that complete picture in mind, here are the 5 ideas worth carrying forward from this lesson. Hubs are history, switches think, in MAC addresses at Layer 2, and routers make decisions on IP at Layer 3. Remember that switches contain broadcasts within a VLAN, while routers stop them entirely at the boundary. Firewalls have evolved from simple stateless filters to full next-gen platforms that understand apps and users. And load balancers split into 2 flavors, Layer 4 for raw ports, Layer 7 for HTTP-aware routing. To make all of this stick, here's a 1-page cheat sheet you can return to anytime. Each row pairs a device with its defining layer and its job, hub at Layer 1, switch at Layer 2, router at Layer 3, firewalls and load balancers climbing up through Layers 4 to 7. Keep this nearby as a quick reference, because once you can match a device to its layer, you can predict exactly what it's capable of deciding. That wraps Lesson 6, and next up is the Stage 1 capstone, where everything from these foundations comes together so you can lock it all in before we move deeper into the curriculum. Review the cheat sheet, sit with the layer-to-device logic, and meet me in Lesson 7 ready to put it to the test. For more, head to dargslan.com or the YouTube channel. See you there.